Good morning everyone. So in last class we have discussed about what? Multiplexers. Okay. So what is meant by multiplexer? It is a device that is used to select the binary information from many lines and transfer it to single line. Okay. So simply it is called a data selector. It will select a binary input and send it to the single line. So in multiplexers we are seeing 4 by 1 multiplexer and also 8 by 1 multiplexer. So in multiplexer, to select the input lines, two more additional lines are used. These lines are called selective lines. These lines are called selection lines. Okay, according to the formula 2 to the power of n is equal to 4. So here 2 to the power of n is equal to number of input lines. So n is equal to number of selecting lines. And also we read about more one function demultiplexer. Here demultiplexer will provide the opposite function of multiplexer. Multiplexer will convert many to single. Demultiplexer will convert single to many. Simply it transfer the data over single line to one of many lines. And it will transfer the data from single line to one of many lines with help of selection lines only. Selection lines S0 and S1. Okay. So in this way the demultiplexer works. And according to the truth table we can express the logic and also we are able to draw the circuit. It is already over. Next topic is decoder. So it is a device which is used to decode either the hexadecimal or the decimal or the octal numbers into the binary information. So simply decoder is a device which is used to decode the given information. So in decoders 2x4 decoder and also 3x8 decoders are there. So here the phasing of 2x4 and 3x8 is also came from the mathematical expression of 2 to the power of n is equal to number of outputs. So here 2 to the power of n is equal to 4 means the decoder having the 4 output lines, n is equal to number of inputs. So 2 to the power of 3 is equal to 8 means 3 input lines are there, 8 output lines are there. So these are the different combinational logic circuits. So in our last class we finished multiplexer, demultiplexer, decoder. And while coming to the previous class, in combinational logic circuits, half adder, full adder and also parallel adder, serial adder, one's complement, two's complement, adder and subtracted over. So while coming to today's topic, today we are going to discuss about BCD to decimal decoder circuits and decimal to BCD encoder circuits and also the need of tri-state buffer and also the types of tri-state buffers. Here see our first topic is BCD to decimal decoder circuit. Okay. And also BCD to decimal to BCD encoder circuit. So first of all, of course it is decimal to BCD encoder. Already I explained you what is meant by BCD. Already I told you in our first sessions what is meant by BCD. So here BCD indicates binary coded decimal. For example, if in decimal 10 is equal to equivalent of 10 in binary coded decimal is, here we write equivalent number of 1 0 0 0 1 as well as 0 0 0. This is binary equivalent. But while coming to the decimal, 1 0 is equal to, decimal is converted into only binary 1 0 1 0. So this is decimal 10 is equal to 1 0 1 0 in binary, 0 0 0 1 0 0 0 0 in BCD. Okay. So 10 is equal to 0 0 0 0 1 0 0 0 0 in BCD and 1 0 1 0 in binary form. So here BCD means binary coded decimal. Each and every number, each and every digit. For example, if it is 11, you write equivalent binary number of each digit. For one you write, as well as again for one also you write. So this is called BCD. So clearly observe here, binary is different from BCD. Okay, binary is different from BCD. Binary means just we write combination. So BCD means we write equivalent number, binary number of each and every digit, equivalent number of each and every digit. Okay, and see here, while coming to the next one, here our encoder will convert decimal or hexadecimal into binary form. Decimal or hexadecimal. Encoders are required at the interface of man and machine communication. Why? Because here it will convert decimal or hexadecimal into binary now. So decimal and hexadecimal can be understood by the human beings. Decimal and hexadecimal can be understood by the human beings, but binary can be understood by the machine. Decimal and hexadecimal understand by the human beings. Binary can be understood by the machine. So that encoders acts like a interfacing devices. How it acts like? Encoders acts like interfacing devices. Okay, so that it are able to convert decimal or hexadecimal into binary. Here the decimal or hexadecimal numbers can be understood by the human beings, and the binary numbers can be understood by the machine. So that encoders are required to the interfacing of man and machine communication. So for transmission of data between various digital subsystems that do not employ the same code. Okay, means while sending, we are sending decimal data, and while receiving, if it able to receive only the binary information, means while sending the data is in another form, while receiving the data is in one other form. So there we use encoders. Okay, senders and different number system, receiver receive different. Sender and receiver number systems are not same. Sender will send either decimal or hexadecimal. Receiver will receive only the binary. So where we are using encoder. So simply the encoder is a device which converts decimal or hexadecimal into binary form. Cause of decimal and hexadecimal understood by the human being, and binary is understood by the machine. So the encoder is used as an interfacing device between the human being and machine, and also between the two stages, where the two stages will working with different data. One system work with binary number, the other work with either maybe the hexadecimal or it may be the decimal system. Okay, and while coming to the next one, see here simply in simple one word answer, it is a logic circuit. It is used to convert one form of data into other form. So that one form is maybe either octal or maybe hexadecimal or it may be decimal. But the other form, what is the output form? The encoder will convert one form into other form now. So what is the output? Binary. So what is the input of encoder? Decimal, or it may be hexadecimal, or it may be octal. And what is the output? Binary. And the input of data may be in any form other than binary. Input may be. Why? Because the output of the encoder is binary. For example, if I would like to draw the block diagram like this, okay, this is the output side and this is the input side. The input side, it may having either octal number system, either decimal number system, either hexadecimal number system. But the output side, it having only binary number system. Okay. Finally, encoder is a circuit which is used to convert one form of the data into other form. But what is that other form? Binary. So the output of encoder is only binary. The output of encoder is only binary. It's clear. Okay. The input may be either the octal or the decimal or hexadecimal, but input not a binary number. Input of encoder is not a binary number. It is only either octal or decimal or hexadecimal, but the output is only binary. Input is not binary number, but the output is only binary. Cause of the output is binary, so binary to binary conversion is not possible at all. So that input of encoder system is only either the octal or the decimal or the hexadecimal. Output is only binary. Is it clear? And the encoders can also design by using combinational logic circuits. Combinational logic circuit means what are the combinational logic circuits? Whether it may be the gates. Okay, while coming to the gates, 7 gates are there: basic gates and universal gates, special gates. Okay, what are the basic gates? Here the basic gates are AND gate, OR gate, NOT gate. And while coming to the special gates, XOR as well as XNOR. And while coming to the universal gates, NAND gate as well as NOR gates. Okay, and see here, while coming to the circuit diagram, it may be the combination of sometimes it may be the combination of half adder, full adder, and also other different circuits, parallel adder. Like, why? Because they are also combinational logic circuit. So under combinational logic circuits, all are occurred: adders, subtractors, and basic gates, universal gates, all gates. So here our encoder is designed with help of combinational logic circuits. So here we are taking the help of OR gates. How many number of OR gates are there in circuit? Our circuit, 2 OR gates are there. How many number of OR gates are there? 2 OR gates are there. So first one is produce the output Y0 and the second one produce the outputs Y1. So see here the input is A, B, C, D. The inputs, 4 inputs are there: A, B, C, D. How many number of outputs are there? Y0, Y1. For example, if I would like to convert our number one, for example, 1 is applied across A, so it is equal to 0, 0. Next the number 1. If we toggle this 1, next here the output is 0, 1. If push button switch 2 is pressed, so here it consisting of what? Push button switches. How many number of push button switches are there here? 4 push button switches are there. Of course the numbering is started from 0, 1, 2, 3. But how many number of push button switches are there? 4 push button switches are there. So by pressing the switch, the voltage must be passed through the circuit to produce the output. For example, switch 0 is pressed. The output produced across the OR gates are 0, 0 only. Okay, and if button 1 is pressed, okay, button 1 is by pressing switch 0, the output is 0, 0, means here the output OR gates are not connected to the line A. By pressing this also, no output is produced. Why? Because these two gates are not connected to the line A. And by pressing 1, it is connected to B. So one of the input is high, so output is 0 and 1. Okay, is it clear? So by pressing 0, okay, these two gates, input of 2 OR gates are not connected to the line A, so the output is 0, 0. So 0 is equal to how much? 0, 0. Okay, we'll see the next case. By pressing the button 2, pressing switch button 1, what we are getting here? OR gate is not connected to the B, but Y0, first OR gate is connected to B, so that it will produce 1, it is produced 0. So what is 1 is equal to how much? By pressing 1, we are getting 0 and 1. Okay, next by pressing 2, that push button switch 2, so this line is connected here, so now it is 1, it is 0. Okay, next, while coming to the third switch, by pressing this switch, it produces Y0 is equal to 1, Y1 also is equal to 1. Okay, both are is equal to 1. So see here, by pressing 0 we are getting 0 and 0, by pressing 1 we are getting 0 and 1, by pressing 2 we are getting 1 and 0, by pressing 3 we are getting 1 and 1. So see here, by observing cleanly, 0 means in decimal or octal or hexadecimal, 0 0 in binary. 1 is a decimal number, 0 and 1 is binary number. If 2 is a decimal number, 1 and 0 is binary. If 3 is a decimal number, 1 and 1 is a binary number. Okay, if of course they may be also till 7 octal number, also hexadecimal number. Finally, it converts this decimal or octal or hexadecimal form into equivalent binary form. It is very easy. The circuit construction is also okay. How many number of gates are used in the construction? 2 gates are used. How many number of push button switches are used? 4 push button switches are used. And here, how can we write the logical expression? Y0 is equal to B plus D. Y0 is equal to B plus D. And Y1 is equal to C plus D. Y1 is equal to C plus D. Here you observe cleanly, A is not connected or not involved in the logical expression. A is not connected to gates and it is not involved in the logical expressions. Is it clear? By pressing switch 0, we are getting 0 0. By pressing switch 1, we are getting 0 and 1. By pressing 2, we are getting 1 and 0. By pressing 3, we are getting 1 and 1. Is it clear? Okay. So in this way, the encoder will works. Okay. One second. It happened. Okay, see here, this is the truth table. This is the truth table of 4x2 encoder. Okay, here the position of push button switch in the truth table is indicated as 0. Already I explained. So here it is 0. Okay, here it is 0. So then it is written as 0. Here the push button switch is 1. Push button switch 2 is there, 2. And 3 is there, this is 3. Okay, the 0 equivalent, what we are getting here with expression Y0 is equal to B plus D. Here we are getting 0 plus 0. With help of 1, 0 and 1. By pressing switch 2, we are getting 1 and 0. By pressing switch 3, we are getting 1 and 1. Already explained this. So here we arrange this in the form of truth table. So once see the slide, whatever I explained, it is there. When the push button switch 0 is pressed, then Y1 and Y0 are gates having low outputs. Therefore, the output word is 0 0. If the button 1 is keyed means pressed. The Y1 and Y0 are gates have low and high outputs. Therefore, the output words Y1 Y0 is 0 1. Similarly, when the button 2 is keyed, the output word is Y1 Y0 is 1 0. And when button 3 is keyed, here the word pressed is replaced with keyed. So the output word is Y1 Y0 and 1 1. Okay. And see the slide. Now while coming to the next slide, decimal to binary encoder. Decimal to binary encoder. Okay. So here in decimal to binary encoder, in previous one that is BCD. So here it is decimal to binary. Only it will convert decimal to binary. Okay, see here how many number of inputs are there here? 10 inputs are there, they must be written from 0 to 9. How many number of inputs are there? 0 to 9. So total 10. And how many number of gates here we are using to construct the circuit? 4 gates are used. What is the name of the gates? OR gates. How many number of gates are there? 4. 1, 2, 3, 4 gates are used. Okay. So with help of 4 gates, how many number of outputs are produced? 4 outputs are produced. What are the 4 outputs? Y0, Y1, Y2, Y3. So which outputs are produced? How many number of outputs are produced here? 4 outputs. Y0, Y1, Y2, Y3. And here in the circuit, how many number of push button switches are there? 10 push button switches are there. So first one is indicated with a 0 push button switch. Next one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So serially we number the push button switches from 0 to 9. So total how many number of push button switches are there? 10 push button switches are there. And see here, while writing the logical expressions for Y0, okay, how can we write the logical expression of Y0 means? See here, Y0 is equal to, it is connected to first push button switch, one push button switch. If we write like for example it is A, B, C, D, E, F, G, H, I, J, if we write like that. So now the logical expression is what? B into D into, here it is F into. So like that we write the expression. Is it clear? And Y1 is equal to push button switch 2 as well as 3 as well as, here it is 6 as well as 7. So in this way simply Y3 is equal to 8 into 9. Okay. So this is the circuit diagram of decimal to binary encoder. How many number of push button switches are there here? 10 push button switches are there. How can we number this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many number of OR gates we are using here? 4, 1, 0, Y1, Y2, Y3. And by pressing 0 we are getting what? 0, 0, 0, 0. By pressing 1 what we are getting? All are 0. Why? Because only this gate is connected here for 1. So we are getting all are 0 and Y0 is equal to 1. By pressing 2, so first 2, second gate is only connected. So here it is 0, 0, 1, 0. And for 3, for number 3, it is connected, Y1 is connected to 3 and also Y0 is connected to 3. So these are 1, 1 and these are 0, 0. And while coming to the next one, for 4, only Y2 is connected for 4, no other gates are connected to the 4. So that it give the outputs remaining are is equal to 0. So 0, 1, 0, 0 we are getting. And next 5. For 5 you see this Y2 is connected and it is not connected and Y0 is connected. So we are getting 0, 1, 0, 1. Okay. Next. And while coming to the next 6, see for 6 Y2 is connected and also Y1 is connected and Y0 is not connected. So we are getting 0, 1, 1, 0. And okay, next 7. See clearly it is 7 is connected to Y2 here and also Y1 here and also Y0. Means 7 is connected to, while pressing the button 7, power is given to both Y2, Y1, Y0. So that 3 gates will able to produce the output except Y3. So 7 is equal to how much? 0, 1, 1, 1. Okay. Next last one 8. So 8 is connected to Y3 here, and no other gate is connected. Only Y3 OR gate is connected to 8. No other gates are connected. So Y3 only produce the output, so that all other are 0, only we are getting Y3. So that it is equal to 1 0 0 0. Okay, and while coming to the next one, 9. See here, 9 is connected to this Y3 as well as this Y0 and no other gates. So that Y3 produce the output, Y0 produce the output, and these two are is equal to 0 0. So finally 9 is equal to 1 0 0 1. Okay, so in this way it will convert the decimal numbers into binary numbers. The circuit construction is simple. It is constructed with help of only 4 gates. It is constructed with help of only 4 gates, 4 OR gates. Okay, and 9 10 push button switches. By pressing the push button switch, what happened inside in the circuit means, here we are applying 5 volts power supply. Okay, that power supply must be circulated. That power supply must be circulated through the circuit. Power supply must be circulate around the circuit. Is it clear? Okay, one second. Sorry. So by pressing the switches, any of these switches, this 5 volts power supply passed through those conductive lines, or these are the conductive lines. So by pressing the switch button 9, the power supply 5 volts must be given to the OR gate Y3 and Y0, so that we are getting 1 0 0 1. So in this way the power must be circulated through the gates and it will produce the output. So with the help of switches, here we are converting the decimal numbers into the binary numbers. Okay, this is the circuit diagram. Okay, technical issues there. Okay, see here, this is the truth table of our circuits. So our BCD encoder truth table is here. Okay, will not support the multiplication. Okay, this is the truth table. Once see the truth table, here the first, already I explained you, by pressing the switch 0 we are getting 0 0 0 0, and by pressing the switch 1 we are getting 0 0 0 1, and pressing the switch 2 we are getting 0 0 1 0, and pressing the switch 3 we are getting 0 0 1 1, and while pressing the 4 we are getting 0 1 0 0, and by pressing the switch 5 we are getting 0 1 0 1. Okay, and while pressing switch 6 we are getting the outputs 0 1 1 0, means the output Y1 is produced and Y2, and pressing button 7 we are getting 0 1 1 1, and by pressing 8 we are getting 1 0 0 0. Okay, and by pressing 9 we are getting 1 0 0 1. So in this way the output will be produced. Okay, and see here, while coming to the next topic, tri-state buffer. So what is our next topic? Tri-state buffer. So the name itself indicates, so buffer means it simply pass whatever the input we are connecting to some circuit is simply passed to the other circuit. So here it is tri-state buffer. Tri, the word tri indicate what? Tri indicates 3. So in this buffer, how many number of states are there? 3 states are there. What are the 3 states? Sorry. One is low, other one is high, and more one is floating state. The name itself indicates in tri-state buffer how many number of states are there? 3 states are there: high, low, flat. Okay, in tri-state buffer how many number of states are there? 3 states are there: high, low, flat. With the help of these 3 states, whatever the input we are applying to the buffer is passed to the next stage. So see here, in digital systems and other IC functions have tri-state buffer that allows to interface between the buses. What is the need of buffer? Simply these acts like a interfacing devices, transfer the data from one device to other device. They transfer the data from one device to other device. And when 2 or more devices are connected to a common bus, tri-state buffers are used to prevent more than one device to access the bus at the same time. For example, see here, one bus is there. So in this bus, 4 devices are connected to receive the data. At the same time, these all devices, device 1, 2, 3, 4, would like to receive the same data. Okay, but because of internal problem, at a time the 4 devices will try to receive the data. Because of that, maybe there will be a chance of getting error. So that in between stage to stage, here we are using buffers. So because of using buffer, after receiving the output or after sending the output of first stage, then it is passed to the second stage, and then it is given to the third stage with the help of buffer. Next it is given to the, so cause of this no disturbances are there, and only one device will be accessed by the bus. After accessing of first device, only the other devices can be accessed. Means at a time how many number of devices will be accessed or in enable condition? Only one device. After accessing of one device, the buffer should connect the output of first one to the second one. Then only it will be accessed. That means what, at a time how many number of devices will be accessed? Only one device will be accessed at the same time. So in this way, the devices will be accessed one by one. And see here, by replacing open collector outputs with tri-state buffer, the switching time needed to change from low state to the output stage is reduced. Okay, by small modifications in the tri-state buffer by using collectors, output may be increased. And see here, when large data transfer is required, the circuit quite complex. In order to simplify the wiring and design, the bus organization is used. Okay, when large data transfer is required, the circuit is quite complex. But to simplify that, here the wiring and designing bus is also there. But bus combination means what? It is the group of wires. Bus means what? Group of wires. Already we watch it is in the connection of this connection, not a cable connection. If we are using D to H video can, or in our laboratories also to connect CRO to power supply or CRO to other devices, we are connecting some conducting lines. We take the help of conducting lines. So these lines are called, these wires are called buses. So bus means what? Simply it is the group of wires. And is the data points to be sent are connected to the same. Okay, the data points to be sent are connected to the same bus. And a switch connect the output of the gate to the bus. When the switch is open, there is no data transfer. So simply here the tri-state buffer is acts like a switch. Okay, if the switch is open, no output is connected. Okay, why? Because buffer is acts like a switch. If switch is open, no data is transferred. If switch is closed, the data is transferred from one stage to other stage. So in this way, the buffer will connect one data point to other data point. One see here. For example, here one device is there, device 1, and device 2 is there to receive the data, device 3. Here we are using one buffer, okay, and here also we are using one buffer. When the device 1 is accessed with inputs, this buffer is in open condition. Buffer is in open condition. When the data accessed by the device 1 is finished, at that moment only the buffer will connect this output to the device 2. At that moment only it acts like a short circuit. Until the input is processed, the buffer is in open condition. When the data is processed, after the finishing of data, the buffer will collect the output of device to the input of second device. So in this way, the device 1 is connected to device 2, device 2 is connected to device 3. For example, if buffer is not there, during processing also the data will be connected to D1. If buffer is present, after whole data is processed by D1, only it is connected to D2. Only after processing it is connected to D2 with help of buffer. If buffer is not there, in process also the data is connected. Because of that, not whole result is given to D2. Again, the D2 is not processed wholly, it is connected to D3. So that finally errors are produced in each and every stage. But with the help of buffer and opening it, after processing the inputs by the first stage only, these connected to the second stage. And by using more buffer between the second and third stage, after the data is processed by the second stage, only it is connected to the third stage. So in this way, the switches buffers acts like a switches. When switch is closed, the output is high or low, and when switch is open, output is flawed. Okay, it is not connected, simply it acts like a open circuit. No output is connected. Okay, and while coming to the next one, see here once. This is the circuit of tri-state buffer. So here see, the tri-state buffers are designed with help of semiconductor devices. Those semiconductor devices are what? Transistors. How many number of transistors are there here? 3 transistors are there. Transistor 1, transistor 2, transistor 3. So tri-state buffer. How many number of states are there? 3 states are there. What are the 3 states? One is high, other is low, other is flat. So to indicate these 3 states, high, low and also flat, how many number of transistors are used here? 3 transistors. So for the first transistor T1, base of the transistor T1 is connected to one input. The name of this is called enable. And emitters of T1 and T2 are connected to ground. Emitters of T1 and T2 are connected to ground. Base of T1 is connected to enable. And collector of T1 and base of T2 connected together. Base of T1 and collector of T1 and base of T2 connected together, and they must be given to supply voltage VCC. So simply base of T1 is connected to enable, base of T2 is connected to VCC, and base of T3 is connected to D in line. So here three inputs are there. One is D in, other is enable, and two supply voltages are there, VCC. Okay, so base of T1 is connected to enable, base of T2 is connected to VCC, base of T3 is connected to D in, and collectors of T2 as well as T3 again connected to supply voltage, so simply collector of T1 is connected to supply voltage, collector of T2 is connected to supply voltage, collector of T3 is also connected to supply voltage, and finally the output is appeared across the emitter of T3. Emitters of T2 and T1 are connected to grounds, but output is appeared across T3. So now you tell me, buffer is used in between two stages. Now which terminal is connected to the device? D in is connected to the first device, and D out is connected to the second device, and VCC supply voltages are used to enable the buffer. By application of supply voltage and activating the enable signal, the output must be passed from one stage to next stage. Output must be passed from one stage to next stage. Okay, so this is the circuit diagram of tri-state buffer. How many number of transistors are there? 3 transistors are there. Emitters of T1 and T2 are connected to grounds. Output is available at emitter of T3, and enable signal is given to base of T1, and collectors of T1, T2, T3 connected to supply voltage VCC. At the same time, base of T2 also connected to VCC. Base of T3 is connected to supply voltage at the same time D. So finally, output of first stage is connected to D in, and the input of next stage is connected to D out. Okay. And see, while coming to the operation, once you check the slide, if the data is to be transferred is given at D in, the output is taken at emitter. Already I told this. So simply enable is used like to open or close, means after application of enable signal only the circuit is in active condition. If enable is not there, even though input is present, the output is not produced. Is it clear? After giving the enable only, the input is transferred to the output. Even though the input is present across the input terminal, if the enable signal is not there, that input is not processed or passed from one side to other side. Even though the input is present, in absence of enable signal, output is not produced. If the enable is present, then only the input is passed from one side to other side. Okay, so now see here, to send the information from one stage to other stage, okay, when enable is low, the transistor 1 is in cutoff condition and T2 is saturation to pull the base voltage to ground, means so the output is in flat condition. So when it is high, T1 is in saturation, so cause of the T2, T3 is also in saturation region. Okay, so now say in the symbol it consisting of 3 terminals one is D in, other is enable, next one is DO. So how many number of terminals are there in tri-state buffer? 3 terminals are there. What are the 3? One is input D in, output enable. Even though the input is present here 5 volts, if enable is 0, output is not produced. If enable is high, then we applying the input, then output is present. Means what? If enable signal is applied, only the input is transferred to the output. If enable signal is not there, input never transferred from one side to other side. So finally, why it is called a tri-state buffer? 3 states are there. What are the 3 states? If we apply low signal, high, high in presence of enable. Low, low signal. If enable is not there, even though 1 and 0 are present, nothing is there here. So how many number of states are there? 3. The last stage is called floating. Okay, see here. If enable is 0, D in is 1 or 0, irrespective of D in, output is 0, open. Now enable is 1, input is 0, the output is also 0. Same input is passed, that is only the aim of buffer. If it is 1, the input is 1, again the output is 1. Means what? By application of enable signal only, the input must be transferred to the output. If enable signal is not there, input not transferred to the output side. Input not transferred to the output side. Okay? See here. In normal open type, the switch open when the enable is 0 and closed when the enable is 1. In normally closed type, the buffer open when the enable is 1 and closed when the enable is 0. Hence, for a normally closed, instead of using the term enable, here we are using disable. In normally open, it is called enable. Normally closed, it is called disable. And see here, our last circuit is BCD to decimal decoder. So here it is a 4x10 BCD to decoder circuit. BCD to decimal. For example, if we are applying 0, 0, 0, 0, the Y0 produce the output. Y0 only produce the output. Why? Because Y0 connected to A, B, C, D. And if we are applying 0, 0, 0, 1, Y1 produce the output. If we are applying 0, 0, 1, 0, Y2 produce the output. So in this way, the gates are arranged and gates are arranged. With help of NOT gates, 0 is converted into 1 and 1 is converted into 0. 0 is converted into 1 and 1 is converted into 0. Okay. So in this way, the binary numbers are converted into decimal. See here, this is the truth table. Up to 0, 0, 0, up to 15. Okay, 0, 0 to 1, 0, 0, 1. So here for the first 0, 0 only, Y1 produced. For 0, 0, 0, 1, Y1 only produced. 0, 0, 1, 0, Y2 produced. 0, 0, 1, 1, Y3 produced. In this way, the output will be produced. And see here, this is M by N decoder. Here M outputs are there, M inputs are there, N outputs are there. What is the relation between the outputs and input? M less than or is equal to 2 to the power of N. M less than or equal to 2 to the power of N. Okay. And decimal to BCD encoder circuits will always depends upon the formula M 2 to the power of N less than or is equal to 2 to the power of N input line. Okay. Is it clear? The slides will help you. So example 4x2 encoder, 8x3 encoder, 10x4, 16x4 encoders. Okay. And see here, here the multiple choice questions also there once you check the slides. So now I would like to conclude the class. Okay.